And what is the definition of the sequential circuit? You see, like the second sentence I highlighted, it's the like exact definition of a sequential circuit. It says that when we need the circuit to change its value with consideration to its current state, as well as its input. So input is of course input, no question. But in addition of input, the sequential circuit considers the current state as well. Okay, so let's see one example of combinational circuit. It's the AND gate. The AND gate, let's we apply 0 0 to an AND gate. What is the output? The output is 0. Now, let's say 1 second later, we change the input to 1 1. What is the output? This gate only considers the input, and based on the input determines the output. It doesn't consider the output, the current output. It doesn't care that the output is 0 or 1. The only thing that this gate considers is the inputs. But sequential circuits, in addition of the input, they consider the value of the output, and based on these considerations determine the output. Okay, so let's guess. It should be like the circuit should be more complicated than uh, combinational circuits, because in addition of inputs, the outputs also are being considered. Okay, so let's see. Before before discussing the first combinational sequential circuit, I want to talk about clock pulse. Okay, clock pulse. The clock pulse that because in sequential circuits, the events can be sequenced like a program in a computer. So the programs it's supposed to be a program is supposed to be like executed line by one, line by line in a sequence. Okay, so in sequential circuits, the state changes are controlled by the clock. What is clock? Clock is a special circuit that sends electrical pulses through a circuit. And this one is a clock. This one is a clock pulse. The clock pulse is like a voltage on a wire, which is high, low, high, low, high, low. Exactly like heartbeat. Okay? So just like pulsing between high value and low value. Okay, and do it like with the constant frequency. Okay, based on the frequency determines how fast this clock signal is changing between ones and zeros. Okay, so this one is like a clock cycle that we need to know, because for sequential circuits, of course, we need to work with clock pulses. Okay, so now that we know what is clock, let's go and see some uh, parameters of each clock cycle. The state changes only when a clock ticks. Okay, so you see how many times the clock ticks here? 5 times. So a state can be changed 5 times with this 5 clock cycle. The state, depending to the circuit, can be changed in a rising edge of each clock, rising edge. Okay, the state can be changed in a rising edge. The state can be changed in falling edge. Okay, the state can be changed in high level when the clock is high. The state can be changed in low level when the clock is low. So based on the circuit, we have four different possible devices which are rising edge sensitive, the state changes in rising edge, devices that are falling edge sensitive, devices that high level sensitive, and devices that are low level sensitive. So depending to their circuit. Okay, so and it's like a definition. It says that if the circuit changes in the rising edge or falling edge, we call it edge triggered circuit. And if a circuit change its value in high level or low level, we call it level triggered circuit. Okay, so it's like naming of the systems. So if a system is like level triggered, it means that the value of the, not the value, if the circuit is level triggered, the state will be changed in the like high level or low level. If the circuit is edge triggered, the state changes in falling edge or rising edge. Okay, question. Okay, so it might be a little confusing, but don't worry. It's just defining a clock cycle. When we move forward and we see this clock pulse in the actual devices, it makes more sense. Okay, so don't worry about the circuit if you don't like get the entire point of clock circuits. And one thing that we should know in sequential circuits, I mentioned that a sequential circuit consider its like current state. Considering current state needs something called feedback. Okay, in order to be able to consider the current state, we need to have feedback. What is the feedback? In a simple language, the feedback, when we connect the output of a circuit to the input of the same circuit, we call it feedback. Here, look to this circuit. We have two NOT gates, okay? And the output is feedback to the input. Okay, so this one is a feedback. So let's see how we can retain the value, the state, how we can retain the state of Q. If Q is zero, this zero will transfer to this like feedback to the input of gate number one. The output of gate number one will be one because it's not gate. So now the input of gate number two is one. So output is zero. And again, this zero will be looped back. And this circle will be like looping forever. And the value of the output will be always zero. Now let's assume the output value is one. Output value is one. This one like move back to input of gate one, the output of gate one will be zero, and the output of gate two will be one, and the loop continues. And so if we leave this circuit as is for 2 hours connected to the power, the Q is always one. And it is like the principle of memory. It's exactly memory. When we write an information, a data to a memory, it's the way that the memory retain the information. Okay, so if we put one in the memory location, the one will be like remains retained in the location forever until we disconnect the power. And if we put zero, the zero will be like retained in the queue unless we disconnect the power. So this one is the principle of the memory. Just an example. The memory, like they use a better circuits, which are more efficient. But this one is the like most the simplest example for a memory. Okay, any question? Good. Now that we know what is the feedback and how does the feedback work and how we can retain the data, let's move to the next slide and start to learn one of the like most basic circuit and most principal circuits of sequential devices, which is called flip-flop. Flip-flop. Okay, so the most basic sequential logic component is flip-flop. Flip-flop has different types. The simplest one is SR flip-flop. S stands for set, R stands for reset. Okay, and what is the internal architecture of a flip-flop? Here we have an internal configuration of a flip-flop, SR flip-flop. If you look to this circuit, let's see, do we have any feedback here or no? Of course we do. The first feedback, the Q, like it's feedback to the input of this gate, and Q bar is like feedback to the input of the other gate. So we have feedback. So it means that this device can retain the data. How we show like a flip-flop, the symbol of flip-flop is shown on the right, and we have two inputs, set and reset. We have two outputs, Q and Q bar. Just please note that the Q and Q bar are always complement of each other. If Q is 1, Q bar is 0. If Q is 0, Q bar is 1. And of course, for the flip-flop, we need a clock, which is not shown here. Which is not shown here, but we need like a clock cycle for the flip-flop. And let's see how does it work. How does the flip-flop work? And here we describe the behavior of SR flip-flop by a table called characteristic table. So for sequential circuits, do you hear me, guys? I want to make sure. Just confirm. Oh, okay, good.
Yeah, I can hear you.
Yes, yes, yes.
Okay, good. So I don't want to teach myself. So if the circuit is combinational circuit, we call the table truth table. We already know. But if the circuit is sequential circuit, we call it characteristic table. Okay, characteristic table. Okay, let's see how does it work, the characteristic table. On the left side of the characteristic table, we have all possible combinations for S and R. Of course, S and R are two inputs, and the maximum combinations that they can make is 4 combinations. And on the right, we have QT plus 1. Let me tell you what is Q and QT plus 1. Here is the answer. QT means the value of the output at the time t. At the time t, at this moment. At this moment I'm talking to you, the QT is the value of the output at this moment. QT plus 1 is the value of Q after the next clock pulse. Okay, So if we have this clock pulses here and clock pulse number 1, 2, 3, 4, if we are here, at this time, the output at this time is called the QT, and the output at the next clock pulse is called QT plus. If we are at this moment, with the blue arrow, the value of the Q at this moment is called QT, and the value of the output at the next clock is called QT plus 1. So at each moment, the value of output is called QT, and the value of the output in the next clock pulse is called QT plus 1. Okay, so let's see how to write and how to complete this table, this column. Let's check it by together. I am going to apply the values one by one, and then we can see what is the other. Let's say QS is 0 and R is 0. We are completing the first row. S is 0. What is the output of gate number 1, gate number 2? I want to see who can answer this question. So let me open the line. Okay, if S is 0, what is the output of gate 1? Who can tell me? We don't know. Okay, so let's go with one example that we know. Yeah, it's not good idea to go with this example. Let me first start with the second row. Sorry, I think here is better. Okay, now it's better. So if S is 0, what is the output of gate number 1? We don't know, because it depends to the other output, We don't know what is the output of gate 1. But what about gate 2? Can you guess, if R is 1, what is the output of gate 2? No. I got one answer. It is, okay, two answers. Exactly, it's 0 because it's no gate. If R is 1, definitely the output of gate 2 is 0. If the output of gate 2 is 0, the output of gate 2 is connected to the input of gate 1, and of course S is 0. So S is 0 and the second output of gate 1 is 0. So what is the output of gate 1?
Output is 1.
1. Very good. The output is 1. So if the inputs are 0, 1, the output Q is 0. And the same thing is shown in this row. It says that if S is 0, R is 1, the QT plus 1 is reset to 0. What is QT plus 1? Of course, QT plus 1 is this value. Okay, is it clear, this part? Okay, now let's move to the other example. Let's say we want to determine the third row value. If S is 1 and R is 0, of course the output of gate 1 is 0, the second input of gate 2 is 1, and the output of gate the second is 0, not 1. The second input of gate 2 is 0, and the output of gate 2 is 1. So what is Q? Q is 1, and it's shown here. Okay, The Q is set to 1. Now that we are in this situation, let's just at this moment change S from 1 to 0. From 1 to 0. What's gonna happen? Let's see. If we change S from 1 to 0, does the output of gate 1 changes or no? No, because the second input is 1, and no matter if the input of no gate is 1, 1 or 1, 0, the output is always 0, and the same thing for gate 2. So by changing S from 1 to 0, nothing happened. Nothing happened. Okay? And it's the reason that I say if S and R are 0, the output will be same. There is no change. There is no change. Okay? If S and R both are 0, will be no change. The previous state will be remain. Let me show one more example. And let's say if S is 0, R is 1, gate number 1, gate number 2. The output of gate number 2, of course, is 0. The second input of gate number 1 is 0. The output of gate number 1 is 1. That's it. Now let's change R from 1 to 0. Let's see what's going on here. If R changes from 1 to 0, R will be 0. The second input, the R input of gate 2 will be 0. The second input is still is 1, and the output is still a 0, and no change. We see that no change happening. So if we move for inputs from 0, 1 to 0, 0, or from 1, 0 to 0, 0, there is no change in the state. Okay, the state will remain same. The last possible combination is if both the inputs are 1. If S is 1, 1 is 1, R is 1. The output of both gates are 0, and we call it undefined. Why we call it undefined? Because Q and Q bar are supposed to be complement of each other, okay? Are supposed to be complement of each other. But here we see that both of them are 0, so this combination of the input is like prohibited. You are not allowed to apply 1, 1 to the inputs of like a flip-flop, SR flip-flop. And in the next flip-flop, which is JK flip-flop, we will make sure that this is not gonna happen. So we will like modify the circuit somehow that it doesn't let us to apply both ones to the like inputs or to both inputs. So this combination is restricted and prohibited. We are not allowed to have this configuration. Okay, any question?
All good.
Okay, so few things next Tuesday. So that's for today. Let me stop recording.